Hey guys, in this video I'm going to be teaching you how to solve trigonometric function or equations by factoring. So 5-3 day 2. So when trig functions cannot be combined on one side of an equation, try factoring. And applying the zero product property. So let's do a couple examples and then some u-tries. So example 1, 2 sine squared of x plus sine of x equals 1. When x is between 0 and 2 pi, including 0 and 2 pi. So x is an element of 0 and 2 pi. That way we're not writing, or we're not solving for all values like we did yesterday. So what you're going to want to do here is the same thing we talked about the other day and move everything over. Oh, sorry, just kidding. You can't, you usually want to isolate your trig function, but here we have a sine squared and a sine, and so we won't be able to. So we can use factoring, and when you're factoring, you want to move everything over so that one side equals 0. So I'm going to subtract 1. So now you'll see like we've got something squared and we got this by itself, and then we have our c value. This is when we did this earlier in the year. We're going to use u substitution and let u equal sine of x, and it just looks a little bit easier. So it'll be 2u squared plus u minus 1 equals 0. And that's just a lot easier to deal with. Remember, if you have a leading coefficient, you can use factor by grouping, so I'll review that. Your numbers are also so little that I could see you just jumping right to the factors, but I'll review it because it's good to remember. So remember, this is going to be our a times c, so 2 times negative 1. And this is our b, which is our 1. So what multiplies to negative 2 and adds to 1? 2 and negative 1. And then what we do with that is we rewrite this and replace u with a 2u and a minus u, so that's coming from here. And then we group and factor out the greatest common factor. So a 2u, and we're left with a u plus 1. And then here we can factor out a negative 1. We're left with u plus 1, because we want these two factors to be the same. So then, excuse me, our factors are going to be 2u minus 1 and u plus 1. And at this point, we can substitute sine back in and use the zero product property. So I've got 2 sine of x minus 1 equals 0, and 2 sine of x, sorry, I don't know what I'm doing. It's just sine of x plus 1. Alright, let's double check that, because I keep messing up. 2 sine x minus 1 equals 0. Okay, we're good. So now, it's like yesterday's stuff, but we're just going to do it twice. We're going to manipulate the equation and get the trig function by itself. So add 1, divide by 2, and then ask yourself, when is x equal to 1/2 between 0 and 2 pi? So x, our angle, will give us the sine value 1/2 at pi over 6 and 5 pi over 6. Right? When is our y value 1/2? So pi over 6 and 5 pi over 6, and then that's it. So that's part of our answer. And then we have to go over here to figure out the rest. So sine of x is equal to -1. So when is the y value, because we're doing sine, -1 on the unit circle, and that's only going to happen once at 3 pi over 2. And so there are our final answers. Pi over 6, 5 pi over 6, and 3 pi over 2. Let's do one more example. So 2 sine of x times cosine x equals the square root of 2 times cosine x. Sorry, guys. Although it's probably your fault. Anyways, x is an element of 0 to 3 pi. So that means we're going 2 pi, 3 pi. Okay, so first thing we want to do is rearrange so that we equal 0 on one side, because we can't combine to get one trig function alone. So we have 2 sine of x times cosine x, and then I'm going to just subtract my root 2 of cosine x, and now it equals 0. So now if you look at your two terms, they both have a cosine in common. So I'm going to factor out cosine of x, and I'm left with 2 sine of x minus the square root of 2. And now I'm going to use the zero product property. So cosine of x equals 0, and 2 times sine of x minus root 2 equals 0. So now I can just, for my cosine equation, when is the x value equal to 0 between, 0 and 3 pi? So that's going to happen at pi over 2. That's going to happen at 3 pi over 2. And then because we're going around a little bit more, it's also going to happen at 5 pi over 2. Now for this other equation, we need to solve first. So I'm going to add root 2 on both sides, and then I'm going to divide by 2. And then I've got sine of x equals root 2 over 2, and I'm asking myself, when is the y value root 2 over 2? Between 0 and 3 pi, and that's going to happen at pi over 4, 3 pi over 4, go around the unit circle, 9 pi over 4, because it's positive, root 2 over 2, and then 11 pi over 4. So think of your unit circle, right? Y value is positive, positive, and then it's negative, negative, but then we're going around 3 pi, so we've got 2 more answers. And that's it. So we have, 1, 2, 3, 4, 5, 6, 7 answers for this problem. Alright, so now let's have you guys try. So I'm going to have you guys try this problem first. With your groups, I'd like you to do cosine to the 4th of x plus cosine squared of x minus 2 equals 0. and I want you to find values of x when it's an element between 0 and almost 2 pi. I'm going to give you a soft bracket. So pause the video and try to work through this problem with your group mates. Alright, so hopefully you and your group mates got 0 pi and pi. So I'm just going to talk about it real quick. So when you factor, you get cosine squared of x plus 2 equals 0, and you simplify and get plus or minus the square root of negative 2, which is not possible, so there's no real solutions. And then for cosine squared of x minus 1, you get plus or minus 1. And that gives you the x values at 0 pi and pi. So at those two spots between 0 and 2 pi are when x equals positive or minus 1. And then because it's not including the 2 pi, we don't say 2 pi as well. Alright, let's have you do one more example with your groups. So cosine x times sine x minus 1/2 sine x equals 0. And let's have x be an element between 0 and 2 pi, and this time we'll include 2 pi. So please pause the video and do this example with your group. Alright, so hopefully you and your group mates got 0 pi, pi, 2 pi, and pi over 3 is 5 pi over 3. So this one is a little faster than the previous one. Factor out the common factor of sine of x, and you're left with cosine x minus 1/2, and then we use the zero product property and what we know about the unit circle. And that is it.